There is a tunnel, and machinery inside that tunnel sends beams of energy in a vast circle.
Physicists from around the world were incredibly excited to see the greatest, most advanced high-energy particle collider become operational. After all, they had patiently waited for decades to finally watch this amazing invention revolutionize our knowledge and understanding of the universe. The Large Hadron Collider, built by the European Organization for Nuclear Research, went operational after an excruciatingly long building period in September 2008. But it took the inventors of the machine a good few years to perfect the collider. But since then, the Large Hadron Collider has helped scientists unravel quite a few of the universe's mysteries in various runs. However, recently scientists from CERN announced that when they turned up the Large Hadron Collider with a new maximum beam of energy, they detected something unexpected and alarming. Since this incident, they've been trying to postulate what exactly caused this, but so far all they have are theories that may or may not be correct. Collider is a kind of a particle accelerator that brings two opposing particle beams together so that the particles collide. These colliders may be difficult to construct, but in the field of particle physics, these are incredibly powerful research tools as they reach a much higher center of mass energy than the fixed target setups. Scientists can then analyze the byproducts of these collisions that provide us with evidence and information about the structure of the subatomic world and the laws of nature that govern it. Quite a few of these byproducts are produced only by high-energy collisions, and they decay after very short periods of time. This means it's not possible to study these in any other way. The collider is contained in a circular tunnel at a depth ranging from 50 to 175 meters underground. This variation in depth was intentional, meant to reduce the amount of tunnel that lies under the Jura Mountains so as to avoid the need for excavation of a vertical access shaft there. This variation in depth was intentional, meant to reduce the amount of tunnel that lies under the Jura Mountains so as to avoid the need for excavation of a vertical access shaft there. This particular tunnel was chosen so that CERN wouldn't have to spend huge amounts of money purchasing expensive land on the surface. This would also impact the landscape. An added benefit was the shielding against background radiation that the Earth's crust provides. The initial focus of research by the Large Hadron Collider was to investigate the possible existence of the Higgs boson, a vital part of the standard model of physics that was predicted by theory but hadn't been observed previously because of its high mass and elusive nature. The scientists at CERN speculated that if the standard model was correct, the LHC would produce several Higgs bosons every minute. This would allow physicists to finally confirm or disprove the existence of the Higgs boson. Besides that, the Large Hadron Collider allowed scientists to search for supersymmetric particles and other hypothetical particles. After the inaugural tests in 2008, the first operational run lasted between 2009 and 2013, after which there was a long shutdown for upgrades that lasted till 2015. The second operational run occurred between 2015 and 2018, after which there was another long shutdown till 2022. In this third run of the Large Hadron Collider, scientists were left baffled when on July 7th, a crack appeared in the magnetic field of Earth. This mysterious crack wasn't something that occurred like a lightning flash. It wasn't short-lived, in fact. The crack in Earth's magnetic field remained open for a good 14 hours. This enabled the intense solar winds to stream through the opening and cause huge geomagnetic storms that created some incredibly mesmerizing aurora. Science fiction enthusiasts were pretty excited to learn about this. Some even went as far to suggest that maybe Vecna, the monstrous villain from Stranger Things, might have crawled out into our world through this crack. That's just a die-hard fan's dream that will never come true, sadly. But the geomagnetic storms stirred by this crack did create an aurora so beautiful it was difficult to take our eyes off it. But how should we be concerned about this crack? Well, according to experts, this is nothing to worry about, as such cracks in the magnetic field of Earth are pretty normal. This magnetic field acts as a shield that protects us from solar storms hurled our way by the sun. It is believed that numerous cracks in the field open and close relatively quickly, but these recent cracks have proven that these are capable of remaining open for several hours at a time. Our particle physics experiment eventually begins to suffer from diminishing results after a few years of running. Since the prime results reachable by the device begin to be completed, in the later years proportionally lesser results are seen. The simpler way to deal with this is to upgrade the devices involved, especially in collision energy, luminosity, and improved detectors. Along with a possible increase to 14 tera-electron-volts collision energy, a luminosity upgrade of the Large Hadron Collider referred to as the High Luminosity Large Hadron Collider began in June 2018 that was supposed to boost the accelerator's potential for new discoveries starting in 2027. This upgrade aims to increase the luminosity of the machine in order to improve the chances of visualizing rare processes and improving statistically marginal measurements. Like all the big science projects, LHC is advancing slowly, but it's also providing us access to deeply buried knowledge that was unattainable previously. Run 3 is the next stage of this process, and physicists are expecting it to bring forth quite a few surprises, like the recent crack in the magnetic field of Earth, the remainder